So this is a question 2 of SMO Open section. Find the sum of the following expression. We are going to provide a few methods to deal with this question. The first method, we can combine these two terms. 1 plus 1 plus 2 can be understood as 1 plus 1 plus 2. So this is a 2 square. And for these two, we can understand as 1, 2, 3, plus 1, 2, 3, and 4. Okay, so this is a 4 square. And the pattern will follow 6 square plus 20 square. Since each of this is a factor of 2, we can take out 2 square and we left with 1 square, 2 square, 3 square, all the way to 10 square. So in this case, we can add it and use a formula n over 6, n plus 1, 2n plus 1, where n in this case is equal to 10. So this is 1 over 6, 10, 11, and 21. So this will be equals to 7, and this is 5. So this is 4, and this is 385, and this will equals to 1540. I'll introduce you the second method now. For this second method, we will see that each of the terms is of this form. We know that the summation of r, where r equals 1 to n, is equals to 1 plus 2 plus 3 up to n, and this is given by n over 2, n plus 1. And each of this is a summation of this. So we can say that each of this is summation r plus 1 over 2, where r equals to 1, and now this is equals to 20. So this is actually equals to half r plus 1. If we separate it, we will need to use this again. 1 square, 2 square, up to n square, and this is given by n over 6, n plus 1, 2n plus 1. But now, we can actually get this directly. We can actually get r plus 1 from 1 equals to n is equals to n plus 1, n plus 2 over 3. Prove this later on. So we assume that this is true, and we'll get the answer from here, that is equals 1 over 2, then 1 over 3, and is equals to 20, 21, 22. So this is 10, this is equals to 7, so this is 1540. So we conclude that 1540 is the answer for question 2. Now I spend another 3 to 5 minutes to explain why this is true, and I will give a generalization for this summation. This is a well-known result, and we have to understand how we get this result in the first place. Consider r over 2 r plus 1 minus r minus 1 over 2 r. The common term is r over 2. Then this is r plus 1 minus r minus 1. R minus r will be cancelled off. 1 minus negative 1 is 2. 2 and 2 cancel off, and this is equals to r. And therefore, summation of r from 1 to n will be equals to summation r plus 1 over 2 minus r minus 1 r over 2. R equals 1 to n. Again, we're using the method of difference, and you will see that the first term will be equals to 1, 2 over 2, and for this is 0, 1 over 2. The second term will be 2, 3 over 2, and this is 1, 2 over 2, and so on and so forth. And the last term will be n plus 1 over 2, n minus 1, n over 2. And we can see that a lot of them can be cancelled off. That is all this can be cancelled off, and we left with the term n plus 1 over 2. This is how we get the summation of R. So now we claim that summation r plus 1 from r equals 1 to n is equals to n plus 1 n plus 2 over 3. We use a similar argument and we consider r plus 1 r plus 2 over 3 minus r minus 1 r plus 1 over 3. We can see that they are common term 3 r plus 1, so r plus 1, and we left with r plus 2 and r minus 1. R minus r cancel off, 2 minus negative 1, it will be equal to 3, and you cancel with this 3. So this r plus 1. So using the similar argument as what we have just now, therefore summation r plus 1 from r equals 1 to n will equal to the summation r plus 1 r plus 2 over 3 minus r minus 1 r plus 1 over 3 from r equals 1 to n. After we cancel all the term, we left the last term that is equal to n plus 1 n plus 2 over 3. So this will be the answer. Now we can see the pattern from here. If this is r, this is n plus 1 over 2. If it's r plus 1, it will be n plus 1 n plus 2 over 3. So we have r equals to 1 to n, r plus 1, r plus 2 until r plus k. What will you get for this one? We should have n plus 1, n plus 2 until n plus k plus 1 over k plus 2.